helicopter climbs at a steady rate. So we're talking about rate, so we're probably talking about slope, which should relate to our d values. At 5 minutes climbing, the height is 340 meters. So maybe I'll make a little graph here. So at 5 minutes, it's at 340. And at 15 minutes, it's at 1050. So 340 and 1050. So there's what's happening here. So the sequence for the height of the helicopter when n equals 1 minute. So write the general formula for the sequence. So I want to figure out 1. So that's going to be my a value, my starting point a, which is 1. At n equals 1, I'm going to be at some point here, which I'll call a. I have to try to figure that out. So what things do I need to figure out arithmetic sequence? I need to know the a, and I need to know the common difference, or in other words, the slope. So I want to know how far he's gone up since, the rate at which they're going up. So here's my a value, and then I have 2, 3, 4, 5 is 340, 6, ... And this is n equals 5, n equals 15 is at 1050. Okay, so this is what it looks like. I'm just going to map this all out. N equals 1. I'm going to use this to find my common difference. So I know that they've increased in height 710 meters. And this happened over the number of steps. The change in steps is equal to, well, there's 10 steps between 5 and 15. So I know that my common difference must be the change in the Tn value divided by the change in the n value, which is 10, or 7.1 meters per minute. Okay, or oops, this is going to be 71, not 7.1, but 71 meters per minute. Okay, so then I have my meters per minute. I can always figure out a. I can count backwards to a. I'm going to do it this way. I'm just going to plug it into my equation. So my Tn is equal to a plus n minus 1. My common difference I've worked out to be 71. And if I know I have a pair of n and Tn, which I'm just going to plug into my equation. So there's my Tn and n. So at 340, that's going to be equal to the starting position plus n was 5 minus 1 times 71. And this is just like how I solve my slope and y-intercept problems. And once I get a position, I can just plug it. Once I get my slope, I can just plug in my coordinate to find my y-intercept. And that's what essentially I'm doing here. So 340 is equal to a plus 4 times 71 is 284. So I subtract 284 from both sides, I get a equals 56. So there's my starting term. I can now write my general formula. If n is equal to 1, a is equal to 56. My Tn formula is going to be 56 plus n minus 1, because I'm starting at 1, times my common difference of 71. So this arithmetic sequence is very much like a linear equation. In fact, it's pretty much the same. So how are arithmetic sequences and these linear equations related? Well, if I take a look at the formulas, okay, so let's take a look at the formulas. The formulas are going to be like this. Y equals m x plus b. Okay, so that's a linear equation formula. If I can relate it to my Tn formula, because I know that my Tn value is equal to, well, I have an A value, well that's the same as my, well not the same, but similar to my y-intercept. It's my starting position plus, well if I want to know the number of steps, well that's related to x. It's going to be n, and we have to adjust for the n because x usually starts at 0 because b is a y-intercept when y equals 0. A is when n is equal to 1. So to kind of make them match, we need to minus 1 to make the x and the n match. And then we're going to go up by our common difference, which is the same as our slope. The common difference and slope are the same thing. If we recall going back up here, this d value we found by change in y over change in x. Really, it's slope. So they're essentially the same thing. So what do the graphs of the arithmetic sequences look like? Well, the graphs of the arithmetic sequences are just going to go up like this. We're going to start at some value. Okay, I'm going to just erase that actually. Because normally we start at 1. So we have n equals 1. We're going to have some starting amount, and then we're going to go up by some step. So we're going to go 1 over 3 up, 1 over 3 up, 1 over 3 up. Well, when we do that, we're going to end up with a slope. And we can see that the slope values and the d values are going to be the same thing. And so in essence, the arithmetic sequence and the linear equation end up looking pretty much exactly the same. So what do we notice about the differences in the Tn values? So when we talk about the differences here, this is d, it's always a step of 1. The difference is going to be the slope. So the difference values, d, is really the same as a unit slope. Okay, so slopes we might go have a run of that's not 1, but when we make the run 1, we're essentially making a unit slope, and so the d and the unit slopes are exactly the same.